Hello friends, myself Tina Yashwant Padve and I am working as a lecturer in electronics in Government Polytechnic Mumbai. In today's presentation, we are going to discuss about voltage regulators. After watching this presentation, students will be able to explain block diagram of regulated power supply, define voltage regulators, state parameters of regulators, and explain zener diode as a voltage regulator. First, we will recall block diagram of regulated power supply. We have used DC regulated power supply in electronics laboratory. This power supply consists of 5 main blocks: transformer, rectifier, filter, regulator, and load. Load is connected after regulator circuit. AC mains voltage acts as an input to transformer. This transformer steps down this AC voltage to required value. This step down voltage acts as an input to rectifier circuit. The rectifier used is usually a bridge rectifier and it converts AC voltage into pulsating DC voltage. Pulsating DC means some AC contents are present in rectifier's output. These AC contents are also called as ripples. To reduce these ripples, rectifier's output is given as an input to filter circuit. The filter circuit used can be shunt capacitor, L-type, LC type or pi type. The output of filter is smooth DC voltage with small ripples present in it. The combination of rectifier and filter is called unregulated power supply. The unregulated output of filter circuit is connected as an input to regulator circuit. This voltage regulator is a specially designed circuit whose output voltage is constant. Next, we will see introduction of voltage regulators. It is a circuit which will try to maintain output voltage constant under all operating circumstances. These voltage regulators are used as a last block in regulated power supply, and its output voltage is called as regulated output voltage as it remains constant. Next, we will see factors affecting output voltage of regulators. First factor is variation in output voltage due to variation in load current. That is, output voltage decreases when load current increases and vice versa. Second factor is variation in output voltage due to change in input voltage. And third factor is variation in output voltage due to change in temperature. For a good power supply, this change in output voltage should be as minimum as possible. Next, we will see performance parameters of a power supply. The performance parameters will tell us about how good or bad the performance of given power supply is. On basis of these parameters, we can compare performance of different power supplies and select best one from them. First performance parameter is load regulation. Load regulation is defined as change in output voltage when load current is changed from 0 to its maximum value, that is full load value. Therefore, percentage load regulation is equal to VNL minus VFL divided by VFL into 100, where VNL is output voltage with no load, VFL is output voltage with full load. Ideally, this percentage load regulation for a power supply should be 0, and practically it should be as small as possible. Next performance parameter is source regulation or line regulation. As we know, in power supplies, 230 volt AC voltage is applied at the input of rectifier, and this rectified and filtered output is given to regulator. So, if AC mains voltage fluctuates about 230 volt, the input voltage also changes, and there will be effect on output voltage of regulator. To account this change in load voltage due to change in supply voltage, we define performance parameter, that is line regulation or source regulation. So, line regulation or source regulation is defined as change in load voltage due to change in line voltage in a specified range of 230 volt plus or minus 10% at constant load current. Therefore, percentage source regulation is equal to VLH minus VLL divided by V nominal into 100, where VLH is load voltage with high line voltage and VLL is load voltage with low line voltage, and Vnorm is nominal load voltage under typical operating conditions. Ideally, value of source regulation should be 0, and practically it should be as small as possible. Next, we will see how zener diode can be used as a voltage regulator. As we know, zener is connected in reverse bias condition. The voltage across zener diode remains constant equal to Vz. But the condition is that zener should be operated in the zener region of reverse characteristics, and zener current flowing through zener must be greater than Iz minimum and less than its Iz maximum. Next, working of zener diode as a voltage regulator can be explained under two conditions. First is with varying load, and second is with varying input voltage. First, we will see zener as a voltage regulator with varying load. Consider circuit diagram shown on screen, where Vin is unregulated DC input voltage which is obtained from filter circuit, and Rs is current limiting resistor, RL is load resistance, and Vout is output voltage. As we have discussed, two conditions should be satisfied by this circuit to call it as a regulator circuit. First is Vin should be greater than zener voltage, and second is Iz should be maintained in between Iz minimum and Iz maximum. Let us consider the circuit diagram, where Vin is input voltage and it is constant, and RL is variable. So, as input voltage is constant, source current will also be constant, and if load resistance is varied, then load current will also vary. So, if RL is increased, then load current will decrease, and then source current is constant, and to maintain this current constant, more current will flow through zener, that is Iz will increase. And if RL is decreased, then IL, load current flowing through this load resistance, will increase. And as Is is constant, that is source current is constant, to maintain the source current constant, less current will flow through zener. In this way, the zener diode provides regulating action against variation in load. Next, we will see regulating action of zener against varying input voltage. Consider the circuit diagram shown on screen, where RL is constant and input voltage is varying. So, as RL is constant, load current flowing through RL will also be constant. But as source voltage changes, source current also changes. So when V input is increased, then source current will also increase. And as IL is constant, then to maintain the value of IS, IZ will increase. If Vin is decreased, then source current will decrease, and as IL is constant, and then to maintain IZ will also decrease. In this way, zener diode provides regulating action against variation in input voltage. Now it's time for reflection spot. So pause the video and think which conditions should be satisfied by zener regulator circuit to call it as a voltage regulator. Okay, you must have thought that in zener circuit, input voltage applied should be higher than Vz, and zener current flowing through diode should be in between Iz minimum and Iz maximum. In this way, we have studied about voltage regulators. Thank you.